Hi and welcome to video 8 on this series from Unit 4 Topic 2 of the Specialist Math Curriculum, where we're reviewing forces in the differential functions or differential equations or forces and motions topic. So I'm going to talk about resolving forces in particular directions now. Typically we're resolving forces in that sort of horizontal plane or vertical plane and maybe looking at resultant forces. But in this case we might want to consider some other options. So usually it's most helpful to resolve force in north, south, east, west components, horizontal, vertical components, etc. Occasionally we need to resolve them into other given directions. So if we want to compare to certain motion, etc. So here's some cases, and we can do that fairly easily. We just need to look at the force as a right angled triangle, as you can see here, along the line given, whatever that is, if that's north 30 degrees east, or whether it's 40 degrees above the horizontal, or whether it's along a certain vector. So just have to resolve that force along there. And so I'm going to give you a quick example of this. And in this example, which I've already drawn a diagram for, but I'll show you the example first, we want to resolve a certain force represented as a vector in the direction of another vector. And so it's important here that you see how our work with vectors can come into this. Any other type of example really is just some right angled trig with a well-drawn diagram. It's important to get a good diagram in these cases. Here's my diagram, and it's reasonably accurate. So this is my vector here, I plus 4j. So you can see that I've gone along 1 and up 4. I plus 4j. My second vector is 2i minus 3j. So you can see that's this one here, and I've gone along 2 and down 3, approximately. So the ratios are right. So I want to resolve force 1 against this directional vector. So I drop that red dotted line to create a right angled triangle here that we're dealing with. And the resolution of this will be this vector here, whatever that is, which I'll call R for now, just in my description. So the component of force 1 running along the vector I plus 4j is that component there, and it obviously has the same direction of I plus 4j. So it should be equal to, my answer should be equal to some constant times I plus 4j, because it's a component of that line, so it should be some constant times that. That's what we're looking for. But remember, this is also a projection. Remember that idea of shadows and lines and stuff when we did vector projections. So we're projecting F1 onto the vector I plus 4j. And so F1, and there's a few different projection formulas, but here's one from the formula sheet. And that is that if we're projecting A onto B, then the A projection of the B is A dot B hat times by B hat, which is the unit vector. So in this case, that's going to be F1 dot I plus 4j hat times by I plus 4j as a vector. So of course, this dot product is going to give us a scalar, and that will represent our k, and then this will be our overall resultant force, but it's also a hat, which I've forgotten. So I need to work out I plus 4j hat first of all. So I plus 4j hat is equal to the magnitude of I plus 4j dividing I plus 4j. That will give us the resultant unit vector, I plus 4j, and that magnitude will also be a scalar. So the magnitude of I plus 4j is 1 squared plus 4 squared, and the square root of that. So it becomes 1 times 1 over root 17 times I plus 4j. And so I've got the value of R, as I've called it, is equal to F1, and F1 is 2i minus 3j. So it's equal to 2i minus 3j dot 1 over root 17 times by, so where are we at here, times by I plus 4j, so that's my unit vector, and then that's all times by 1 over root 17 I plus 4j. Now we know that 1 on root 17 is a scalar. It doesn't have to be included in our dot product. So I'm going to bring that out, and I end up with 2i minus 3j dot I plus 4j times by 1 over 17, the root 17's cancel, I plus 4j, and we also know how to compute dot products. So this becomes 2 times 1 plus negative 3 times 4 times by this stuff, 1 on 17, I plus 4j. Got a bit lazy with squiggly vector lines here. And 2 times 1 minus negative 3, or minus 3 times 4 is negative 10. So I get negative 10 over 17 I plus 4j is my vector projection of F1 on that directional vector given. And that just came from the work with my dot product. So there's example 3, and that's the end of this lesson. So I hope that you've found that helpful. If you have any questions, come and ask. All the best.